Okay, so welcome to the session number 1. So today we are going to see the introduction of the CATIA workbench, CATIA software, and Sketcher introduction, Sketcher workbench introduction also we'll see. Okay, so in the demo session, like in this today's session, we'll see the like basic things like how to open the CATIA software, then functionality of mouse buttons also we'll see, then how to open file in the CATIA. Okay, then CATIA UI, like we'll see what is the user experience or user experience. Okay, then CATIA workbenches also we'll see one by one, like what are the workbenches and how to reach there. Then at the last, we'll see the introduction of the Sketcher, then profile toolbar in the Sketcher workbench, how to use the profile commands, and we'll see at the end how to create the sketch using the profile toolbar with the constant. Constant means dimension. Okay, just a minute. Okay, so let's start. So in the demo session, we have seen like what is the CATIA. So CATIA long form for the CATIA is computer aided three-dimensional interactive application. Okay, so this is the long form. If someone asks you what is the like long form for the CATIA, so this is the long form for the CATIA. Okay, computer aided three-dimensional interactive application. Okay, and it is developed by the French software company Dassault System. Okay, so Dassault is the like Dassault System developed this software. Okay, and it is very old software. So it is a mechanical design software that leverages features and parameters to create the design. Okay. So it is specifically we are using to design the mechanical stuffs. There are other uses also like in the aerospace or automotive or consumer goods also. So CATIA is like very vast software. In every domain you can use it. So specifically we are going to see for the mechanical design. Okay. And main competitors for the CATIA is another softwares like Siemens NX, NPTC Creo or Autodesk Inventor. Okay. So if you have the knowledge of these softwares also, so it is easy to understand for the CATIA. But if you are new, no problem. We are going to start from the basic things. Okay. So let's start. Point like if you want to open the CATIA, okay, how to open the CATIA? This is like the thing. Like first, if you install the CATIA, so you can go to the desktop and you can directly double click. Like you will find this icon, you can double click on this and you can open the CATIA. If you double click, so CATIA like will automatically open. Okay. So like this, simply you can double click and you can invoke the CATIA workbench, user interface. Okay. So this is like first thing when you open the CATIA, you will enter in this product structure and here is welcome to CATIA and this all the workbenches ready-made here you are getting. Okay, so directly you can jump from here. Otherwise, you can close it. And this is the product. Product means you are directly coming in the assembly workbench most of the times. Okay, this is a DMU workbench, but product means like you can coming into the assembly or DMU, whatever the present, like last time you work on the workbench, that workbench you will enter automatically. So if you are in a product, this like if you're getting in the this product workspace, so don't worry, you can just go to the start. Okay, and here you can go to the mechanical design because we are dealing with the mechanical design, and you can go to the mechanical design. You can click any whatever like you want to part design, you want assembly, you want sketcher, whatever the specific drafting. Okay, sheet metal design. So here you can find all the workbenches. Okay, so if you want to go to the sketcher, you can simply click on the sketcher. Okay, you want to go to the part design, you can go to the part design. So if you want to go to the sketcher, for example, okay, so you can simply click on the sketcher. Okay, once you click on the sketcher, okay, so here see the sketcher, you directly cannot go into the sketcher workbench. Okay, so you can go via either surfacing, either part design. Okay, so this is a surfacing workbench. The last time I worked in the surfacing, that's why it is showing me the surfacing workbench. Okay, so if you want to go to the sketcher, so directly you cannot shift into the sketcher. Sketcher means 2D, right? 2D things, right? Two-dimensional. But here you can see three-dimensional things. Okay, three-dimensional things. So if you want to shift into the sketcher, you can simply first you need to click on the plane, any plane, and you can here you can find the sketcher this toolbar. Okay. So if you are not able to find, you can right click on this and you can find here at the bottom also. This is sketcher is on. If it is not on, you can click on this. So that work like toolbar will be automatically on. Okay. So you can select any plane. So this is your specification tree. Okay. This is your specification tree. Just a minute. Okay. Okay. So this is, you can see here, this is your specification tree. Okay. Here you can see your part name is there. This part. Then these three planes you have X, Y, Y, Z, ZX. Okay. And then part body there, geometric set is there. And whatever the operations we are doing, it will automatically add below this. Okay. Pad, draft, shell, pocket, pad. So this operation I did to create this part. Okay. So this you can call a specification tree. Okay. So this you can lock your part also. If you click on any white line of this specification tree, you can see this part is turned black, means it is locked. Okay. Now you can move your specification tree. If you want to again unlock, you can just click on this any white line of the specification tree. It will automatically unlock. Okay. So this specification tree is fixed in this side, left side. Okay. Then mouse controls. Okay. Mouse controls are important. So if you go for the mouse controls, so you can see here this 1, 2, and 3. Okay, left side, middle, and right. Right click, right? So see, this is just remember first. Okay, 1, 2nd, and 3rd. First means left, middle, and this is right click. Okay, so mouse controls are important. So here, if you go in the CATIA, and if you click on the right, okay, so you can select anything from the right click. Sorry, left click. Sorry, you can click on the left means one number. Okay, so you can see whenever I'm uh, like keeping my mouse on these stuffs. Okay, it is highlighting. Okay, it is highlighting the operation. Means if I go here, it is highlighting the pad, it is highlighting the draft, it is highlighting the shell, it is highlighting the pocket. Okay, and if you want to select it, just left click. Okay, so it will automatically select, 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 select. Only first number means left click. Okay, left click, you can select anything. This plane you want to select, this plane you want to select. So only left means number one condition. This left click you are clicking, anything you can select, menus, commands, geometry in graphic area, etc. Okay, you can select, then click. Click means icon, dialog box, button, tabs, location, or everything can on. Okay, first condition, you can select anything using the left click, or you can just click on that. Okay, then second means middle thing, middle of the mouse. Okay, so if you click on the middle and if you press it, so you can pan your part. You can see there plus sign is created. Now the mouse arrow, observe the mouse arrow. If you press and keep pressing the middle, so you can see this plus sign is turning, and now you can pan your part, this side, anywhere you want. If you want to pan manually, you can go here at the bottom. Here pan option is there, so you can directly pan also. Okay, but from mouse also you want to pan, just press the middle and you can pan it simply. Okay, then right click. Okay, you can go anywhere and you can right click, so it will on its sub element, sub options here. Okay, for this part body, what are the sub options available? You can center graph, you can reframe on, you can hide and show. Hide, you click, so it will automatically hide. Right click again and show. Okay, so here what is happening, if you click on the right any object, this draft, right click, this all options available for the draft. Shell, right click, you can see all the options. If you want to select only shell, just select the left click. So right, left click. Okay. You click on the right, so it will invoke all these options for the pad command. It will invoke all these options for this part 70. Okay. You want to hide it, part 70, you can hide. If you want to show it, so this all the options are on. We'll see what are the uses of these options also. But these are the mouse controls. Okay. This is a pan. Okay. Then you want to rotate this entity, middle and right click. You want to keep press, middle and right click. Keep pressing. And you can rotate this object. Pan, only middle, keep pressing. Rotate, middle and right click, keep pressing. Zoom in, zoom out, middle and right click. Click and release the right click only. Middle you want to, so this arrow will come, so you can zoom in, zoom out. Okay. You have manual options also here. Okay, in the view toolbar, so you can zoom in, zoom out like this also. But better to practice with the mouse. Okay, this is rotate, directly rotate, pan. Okay, like this with the mouse. Okay, this pan with the mouse, rotate and zoom in, zoom out. Okay, with the mouse also you can do. So mouse controls also you need to practice, important. Okay, it will make a fast work, will be faster if you are working with the mouse. Okay, manually initial stage it is fine, but after some time you can work with this mouse thing. Okay, I hope you understood the mouse controls. Just practice it. That's it. Okay. Then how to open file in CATIA. Okay. How to open file in CATIA. How can you open the file, specific file you want to open the CATIA? So you can go to the file command and here you can find the open option. Okay. Click on the open. Specific file you want to select from the folder and you can click on the open. So it will automatically open. Okay. In the new window. It will automatically open in the new window. Okay. So simply you can open it, right? File, open. Otherwise, here also you have options at the bottom, save, open. You can click here also, you can open it. Okay. Otherwise, shortcut, Control O. Okay. You already know Control O, you can paste and you can open directly. Okay. Keypad shortcut. Okay. So these all the options to open a file you can use. Okay. So here specifically if you see, this is a surface part. So you can see here the extension is cat shape. Extension for the file is cat shape. Okay, so as per the file, the extension will change. Okay, if you go to the part, you can see now extension is cat part. Here you can see cat part. So this is part, right? So that's why this is for solid, you can see cat part. For cat shape, okay, this is surface part. So here you can see cat shape. Okay, like this. So this extension, if you go to the product, it will create a cat product. Okay. So in detail, we'll see in next few sessions. So this is like you can easily open the any file you in the CATIA. Okay. Simple. Okay. Then understanding UI. Okay. So this is specification tree. Then these three planes you can select directly and you can click on that and you can go to the sketcher that will see. Okay. Then this is a top bar. In the top bar also, this all the toolbars. Okay. You can move anywhere. You can keep it at the top also. If you don't want this in the workspace, you can keep it at the top like this. You can add here also, you can keep. Okay. If you don't want, you can just release it here, bottom. Anywhere you can keep this. Okay. So this is a top bar, sidebar, and bottom. Okay. So now your workspace is clean. Okay. And if you see, this is your coordinate system or compass also you can say. Okay, compass. So compass, this is you can see all the axis, z axis, x axis and y axis. Similar kind of thing you can see here also, x, y and z. Okay, and here you can see the three planes, x, y, y, z, z x. These three all are interlinked. Interlink means if I move the object, you can see, observe this and this. Okay, everything is moving same. Okay, 1, 2 and 3, everything is moving in the same direction. Okay, so what is the uses of this thing? This coordinate system, see, you can move this your part using this. Okay, so you want to move this your part in the y direction, so you can click on the y line and just drag your mouse. You can move it in the x direction, you can move it like this. In the z direction, you can move it like this. You want to rotate it, yes, you can rotate like this also. Okay, your part you can rotate in any direction. So this is compass is controlling your part. Okay, so this is very important. So you can find here axis system, because when we are working on the CATIA or any mechanical design, axis system is important. This axis system is common. Common means in every software you will find this. Okay, z axis, x axis and y axis. These 3 points were intersecting, that point you can call as a vehicle coordinate point. Vehicle coordinate point means when we are starting the design, when we are starting the design, okay, so we're starting the design from this point. Okay, so for example, this is your vehicle rough sketch. Okay, so when we are going to develop any automotive, for example, car. Okay, so we are taking the reference, this, for example, front side of the car. Okay, here A pillar, B pillar, C pillar, pillars are coming, right, like this. So for example, this is the front side of the car and this is the rear side of the car. So you can see this point is common. We are taking to design any part. For example, you are designing the rear bumper of the car. So I will take the reference from this point. So here some value will come, right? X is equal to 100, Y is equal to 200 and Z is equal to something like minus 300 or anything. So again, if I want to design this roof rails for the vehicle like this, okay. So I'll take the same point as a reference to create here one point. Okay, so this point will be the common when we are going to design the vehicle. So when we finish the design, every component will stick at the location. Okay, so that's why this everything is interlinked. Okay, so where these three planes are intersecting, that point. Okay, so this point you can see, double click. So here value will be the x0, y0 and z0. Okay, so this is 0, 0 condition. From here, we can start our design. Okay, this top bar, sidebar, this bottom, and you can right click here on the sidebar. Okay, and here you can find all the toolbars available for this specific workbench. Okay, this is surfacing. So for this surfacing, these all are available. Okay, so you can directly go to the bottom. You can go to the customize. Okay, and once you go to the customize, so there in the customize, you can customize the commands. Means here in the start menu, whatever the frequently you are using the toolbars, you can add here. Okay, so for example, DMU kinematic I am using frequently, so you can click here and you can add it. Okay, in this favorites, it is added. So these favorites you can find here. You can see this all favorites. Now DMU kinematics is added. So now I want to shift into the part design. I'll directly here. So I can directly shift into the part design automatically. You can see this all changed. Now I want to shift to the this assembly design. I'll click on the assembly. So automatically I'll shift to the assembly design. So this start menu you can add. You can add using this. Okay, right click on this. Go to the customize. In your CATIA, you can do the setting like this. In the start menu, this generative shape design, part design, VIW fastening. You don't want VIW fastening, just remove it. Okay. Then new workbench you don't want, remove it. Okay, this is whatever you are using frequently, you can add here. Okay, and you can close it or add or remove. Okay, from this everything is available, you can add and you can remove it. Okay, so this is your start menu setting you can do in your CATIA. Okay, so now this is basic understanding required to understand the CATIA uh, user UI. Okay, this UI for the CATIA. So now let's start. Okay, so if you want to start the design, so any design you are starting, it is started from the sketch, right? You're if you, any concept in your mind, what you are doing, you are sketching it, right, on the paper, and then we can think about that how to develop further, right? So here in a design also, mechanical design also, we are starting from the sketcher. Okay, sketcher. So sketcher means, see here, how to start the sketcher means if you want to create a new sketch, okay, you can go to the start menu, mechanical design, sketcher menu bar, sketcher workbench, and then from the menu bar you can click on the sketcher, and any reference plane in the geometric area you need to select. Reference plane, you know, right? X, Y, Y, Z, Z, X. And this is my specification tree, already know. So you need to select any one of the plane. Okay. So which plane we need to select, that is the different criteria. I'll explain you in detail. Okay. In some few sessions. But here, start mechanical design sketcher. Okay. I'll follow this same. Okay. Start mechanical design sketcher. Once I click on the sketcher, it is stating that enter a part name. Part name, if you have specific part name, okay, part 1, part 2, okay, any part name you can write down here. New part, for example, new part 1, okay. And here three options you are getting: enable hybrid design, create geometric set, create an order geometric set. Okay, so hybrid design is the concept where you can work with the part design or surfacing both the workbench. Okay, so if you want to enable, you can enable or you can uncheck this also. So once you uncheck this, you can see create order geometric set automatically off. So it is applicable, create order geometric set is applicable only in a hybrid design. If you enable it, okay. So most of the companies are not enabling it. I'll let you know the reason in some like in mostly in the next session. Okay, why we are not enabling. But just if you don't want, you can click OK. That is also fine. So once you click OK, you can see new part name is coming X, Y, Z, and now you can see part body is coming, geometry set is not coming. Why? Because of that setting. What we did, we enable we uncheck the hybrid design, right? No problem. So now, as per the things, we need to select any plane. You can directly, sorry, okay. You can directly select from here your plane. Either directly you can select from here also, no problem. Okay, so for example, I am selecting this plane. And then here you need to find out the sketcher, this sketcher. And here two options you are getting, sketch and position sketch. If you are not unable to find, just right click on this and go to the here, sketcher is there, right? So you can click on this sketcher and you can shift to the sketcher workbench. Okay. So here select the plane and select the sketch. Okay, normal sketch, first option you can click. Once you click it, now you can see this is changed. Workspace is changed, right? Now you can see only two axes, this and this, vertical and horizontal. Means now you shifted into 2D. So sketch we are representing in 2D manner, right? Whatever in our mind, we are representing on the paper in 2D manner, right? So 2D first we need to create, okay, two-dimensional view, and then we can give three-dimensional, we can apply the material, okay, to create it three-dimensional, right? So if you go to the part body now, so below the part body, you can see sketch is added, right? And here you can see visualization, then this is profile toolbar, okay? Then this is also important, operation toolbar, and this is also, just a minute, okay, this is also important, constraint toolbar, okay? So these are important toolbars for the sketcher, profile, operation, and constraint, okay? So here, once you finish this thing, and if you go further, so here, profile, okay, profile toolbar, constraint toolbar, operation tools also will see. But here in the profile toolbar, we'll create our sketch using this different shapes available directly. In the constraints, we'll apply the dimensioning. Okay. In operation, we'll clean our sketch. If any extra line be required, trimming operation is there. Okay. This all operation is present in the operation toolbar. Okay. And tools or sketch tools, here you can do the sketch analysis after your sketch completion. Okay. So if I go here and in the profile toolbar, if I select the first command like profile command, and if I draw something like this, okay, anything I am drawing, random thing, okay, freehand sketch, okay. So if I creating this entity using the profile, so you can see here clearly this is the H, this is the V, this is the H, here no H or V, here V, H, means what is the meaning of this thing? Meaning of this thing means this line is perfectly horizontal. This line is perfectly horizontal. This line is perfectly horizontal. But this line is not horizontal, neither vertical. So this all the constraints will automatically come. If you create this line automatic in this profile toolbar. Okay. But this line is not parallel, not vertical. If you want to change it, you can change. Right click, go here and select the horizontal or vertical. Which option you want? You want horizontal, you can select the horizontal. Okay. So after that also you can create this line, right? So if you go to the profile again, okay. So profile command, this is in the profile, first command is profile. The profile command is continuation of the line and arc. Line and arc means you can create the sketch using line and arc in the single command. So if I create one line like this, okay, you can keep properly horizontal also. It will automatically take properly horizontal. It is turning blue means it is horizontal. But if I am deviating it, you can see the color change. It is turning into the white. White means it is not up properly horizontal. Okay. So it is turning into the blue means properly horizontal lines. Okay. If you click it, okay. So once you click here at the top, you can see in the sketch tools, you can get the arc options, tangent arc or 3-point arc. So if you go to the tangent arc, for example, second this turning into the tangent arc. Okay. And if I click here, again the line option will invoke. Okay. And now you can see if I want to join this properly, I'll click here and you can click again the tangent arc. Okay. So it is again on the tangent arc option. Okay. So this commands you can get here separately also, line command, and here you can get the arc command separately also. But in the profile, this is profile is a combination. Okay. If you want only line, fine. You can create only line sketch using the line also. Okay. Any freehand sketch you want to create like this, anything you can create. Okay. Any shape. Okay. No worries. So here, see, now we'll see one small thing here. Just a minute. So this is the thing, and you want to delete this, you can simply select here and you can go to the auto search and you can delete it. Okay. Right click, line object, auto search, delete. Okay. So it will automatically select complete thing. Okay. Then, for example, I want to create one simple sketch. Simple sketch means this sketch I want to create. Okay, this simple sketch I want to create. So here you can see simple profile I need to create first. This simple profile, and then these dimensions I need to give to the sketch for as per the input, right? To create a proper sketch. Okay, so same thing if I do here, if I create the shape. Okay, if I create the shape, same something like this. Okay, I'm doing the freehand. Okay, I'm not taking any dimension, just matching the points. Okay, so this is a shape, similar kind of shape we created, right? So once you create this shape, okay, directly freehand using the profile command, you can create. Okay, then what you can do, you can simply now see here, this color, this sketch is, if I'm dragging the sketch, it is dragging anywhere. Why? Because it is not properly dimensioned. We have not provided any dimension to this sketch. Okay, so there are three constraints. Dimensions means here we are calling the constraints. There are two types of constraint. One is a dimensional constraint and second is your geometric constraint. Means if you go here, you can see dimension constraint and automatic dimension constraint also will be there. So geometric constraint and dimension constraint, the color is this orange. Means this is this both the options you need to keep on. Okay. If it is off, just keep it on. Okay. In the sketch tools here, you can find this. So what is the difference between these two? Dimensional constraint and geometric constraint. Dimensional means, for example, this length I need to provide. So this length is dimension. This radius I need to provide. So that is dimension. Diameter I need to provide. That is dimension, right? So this is, you can call it a dimensional constraint. And what is meant by geometric constraint? Geometric constraint means this is perpendicular. So this is geometric constraint. This line and this line parallel to each other. So this is geometric constraint. Okay. Then you want to keep symmetry of this and this along this axis. This is geometric constraint. Okay. So there is a difference. So either you can use the geometric, either you can use dimensional constraint. Both the combination also we can use. Then we need to create this sketch properly with the as per the input. So these inputs, these dimensions we need to provide. So this first you can see this color is white. So there are three types of constraint types. One is the under constraint, second is fully constraint, and third is over constraint. Okay. So see, in the first condition, this is, we have not provided any dimension to this entity. Means this is under constraint. Means we need to provide the dimension. Okay. But here in the constraint toolbar, this second option constraint, if I am selecting, and if I am giving the dimension to this line, okay, and this dimension, if I am giving something 95.126, you can see this line is turned into the green. What is this meaning? This is meaning means this line is now fully constrained. Okay, so this line only travel in this direction. It cannot travel in this because this dimension is locked here. Okay, so this, when the line is turning into the green, any line from under constraint to the green color means it is fully constrained. Means it is, we are applying it a dimension. Okay, for example, this dimension I'll apply 100 mm. Okay, you can just double click and you can put your dimension. Okay, simply click out. Then again, what I'll do, I'll go to the constraint, and now this horizontal line I'll select from this horizontal axis. Okay, and this is how much? 84. So I'll apply to, for example, 90 mm. Okay, you can see now horizontal line is also turned into the green. Means now you can see this can travel in this direction because here this dimension not provided, but it cannot travel in this direction. Okay, it cannot go here. It can travel anywhere here, but cannot go here. Okay, this line. Okay, and this line is locked. Means these two lines are fully constrained. Okay, once you do two things. once you do one vertical line and one horizontal line from the sketch fully constant, then you can apply the dimension. What are the dimensions? You have the dimensions like this is 10, this is 10. Okay. This dimension is 10 mm, this dimension is 10 mm, this dimension is 20 mm. Okay. So if you go in the sketch, okay, just a minute. Okay. So now this to this, if you see, this is 10 mm, right? You can see this is 10 mm is added. Then next dimension is this to this, right? This is how much? This is how much? This is also 10 mm. Okay, you can see here this dimension also 10 mm. So you can double click it and you can apply the 10 mm. Okay, because we have created it very large scale. Okay, but when we are applying the dimensions, you can see this is automatically changing and it is creating these things. Okay, so you can simply drag this to match your sketch. Okay, like this. Simply you can drag this. Okay, I'll show you proper structure where to create a sketch if you are finding this problem, but just understand the concept. Okay, now this dimension, how much? This dimension is 20 mm and this is 15 mm, right? Same thing we can apply. Go here, select this line. This is 20 mm. Okay, and this is how much? This is 15 mm. Okay, so you can see automatically everything is adjusting. Sorry, you can simply keep this here. Okay, you can just drag it and you can keep it properly. Don't overlap the dimension. Okay, you can make it near to this. Okay, now this dimension and this dimension is bending. So this is 10 mm and this is 20 mm. Okay, so same thing we'll do. This is 10 mm. Okay, and this dimension we want, right? How much this is? This is 15 mm, right? Here 15 mm is there. Okay, so you can simply go here and add the 15 mm. Okay, so you can see now all the dimensions added and your complete sketch turned into the green. Okay, your complete sketch turned into the green. Means what is the meaning of this? Means now your sketch is fully constant. But you can see this 20 and this 20 we have not given the dimensions to the sketch. Okay, why? So see, if I give the this dimensions to this line, you can see complete sketch is turning into the purple color. What is this meaning? The meaning is this dimension is not required in the sketch. If it is given into the already given into the sketch, but if you are following this, you're already the this dimension is given here and here. So what is the meaning of this? So this total height is calculated as a 30 mm and this dimension we have given that is 10 mm, right? So obviously this 30 minus 10 means this is 20. So software will automatically detect that this dimension is not required. You can calculate using this also. So it is over constant means over dimension. If sketch is turning into the purple color means understand that this dimension is not required. You can delete this. Okay, same for here. Here also not required. Why not required? Because already at the top level 15 plus 15, 30 is given. And this dimension also at the bottom 10 mm is given. Means 30 minus 10. Obviously this will automatically, we can calculate 20 mm. Right? So software will automatically detect. So whatever dimensions given in a sketch, it is not mandatory to give all the dimensions. If software is not allowing you. Okay, it is over constraint. So complete sketch should be green. That is the requirement at the end. Okay, not under constraint, not over constraint. Means this is fully constraint sketch. All the dimensions given as per the this sketch. Okay, so if you are working on the sketch now, at the end, what you need to do? At the end, what you need to do? See, the workflow is simple here for the sketch. You need to create a simple geometry. Apply constraint means dimension you need to apply. Analyze the sketch. Analyze the sketch means you need to now analyze the sketch. So you can go to the tools and you can at the end, once your work is finished now, you are confident that everything, every dimension is fine. But for confirmation, you need to go to the tools and you need to click on the sketch analysis command. Okay, you need to click on the sketch analysis either here or in the tools options. Here you can find this. Okay, sketch solving status and sketch analysis. Okay, here also you can see. You can go to the tools, either sketch analysis. So you can see here sketch status implicit profile is closed, means this status is closed. That is what we require. If this is open or this is isolated or anything is coming, means there is a problem. Open sketch is not like it cannot create a like solid model from the open sketch. We cannot create, or isolated means overlap. Okay, so these options will come. Closed status means your sketch is closed, means you can create from this sketch solid part. If you exit this workbench, now my sketch is complete. I'll exit this workbench. Okay, and if I apply this pad, for example, I'm showing. So you can see I can create the solid model from the sketch. And if I edit that sketch again, I can double click on the sketch here. And if I edit, for example, this I want 20 mm. Okay, this I want 15 mm. Okay, I'm editing my sketch. You can double click on this and edit this dimension. This I want 15 mm. Okay, and if I exit from this workbench, automatically it will update. You no need to update manually here because it is interlinked with your sketch. You can double click on the sketch and you can again go into the sketcher workbench. Okay, so this is a simple method of creating sketch from single command, profile command. Okay, so if you have the same thing here, you need to create this sketch. What you need to do? Simply create this M profile manually like this, and you can give the dimensions 30, 30, 30. So first, your axis will be here, axis will be here, right? So this is your vertical axis, this is your horizontal axis. So one horizontal line match with one horizontal axis, and one vertical line match with vertical axis. Match means give the dimensions. And then once you are this line from the sketch, one vertical line turn into the green, one horizontal line turn into the green, then follow the dimension sequence like this. Okay, follow the sequence. Sequence means 30, 30, 30, 10, 10, 10, 10. So think about this dimension in a sequence. First give this, give this, give this, like this. So if you're following the sequence properly, you can create any sketch. Okay, same here. You want to create this, simply create this thing manually. Here your axis is vertical, your axis is horizontal. Vertical axis, horizontal axis. Match one vertical line with vertical axis, match with horizontal line with horizontal axis, and you can follow the dimensions. Same using the constraint toolbar. Simple. Here also you can create simple this shape. This is 40 mm, this is 20 mm, this is 30 mm, this is 30 mm. At the end, sketch should be green, fully constraint, no over constraint, no under constraint. Fully green sketch we want, and at the sketch analysis, it should be closed status. That is the requirement. Okay. So this is the like procedure to create one simple sketch. Okay, so you can create simple geometry, you can apply constraint, analyze the sketch, and modify the sketch also. You can modify the sketch at the any stage. Okay, so this is for the sketcher workbench.